Hey, so first thing that I'm going to do today before I forget is I'm going to take this change that I made and try and make a pull request to the API because I actually need this. I need to be able to hash things for this kind of stuff I'm doing. All right, let's see. I don't think you really need, let me change this real quick before I forget. So let's push that to mine. I definitely put that on my dev accidentally instead of making a branch, so that's fun. So let's see if we can fix that real quick. See if I can remember how to actually fix that. Oh, that's from Sunday. Okay. I think I want to reset dev to head 1. I think that's what it is. No. I am on dev. Maybe it's reset head to nope. Anybody remember the get message or the get command for that? I swear it's reset. All right, let's figure this out. Reset back 1. I'm trying to undo my last commit. Should just be reset, I thought, to the well, that uses revert, but I don't want to commit that. That's not what I want. It's not hard. I don't think I need to do hard. I just need to reset the commit or the branch to that. Reset current head to the specified state. All right, let's try this. Okay, I think that's what I need. Yes, I think that's what I wanted. Perfect. All right, so then I can do a get checkout -b. Actually, what I can do is check this out. And now I can do a, oops. And then get checkout -b, IL hash, and then get push you Josh Watson. There we go. And that way I don't actually have to create a second commit of the same thing, and it still got pushed. And then we can come over here and whoop. Let's see. Oh, why didn't it give me? Should have given me the little thing that says you have a pull request that you can make. Oh, did I? Still push? Oh, I need to delete some of my branches. Ugh. Yep. I might have messed up my my main repo. Oh well. So anyways, got that out of the way. And now let me actually make that a that change in the real version. Let me do an open real quick. I'll be right back. So what I'm doing is I'm just going into my into the actual Python. I'm gonna make this change real quick. Because it gets deleted every single time that you update. So you have to do it again. All right, and now if we go into Binary Ninja, should be able to, oh, it opened on the other side, sorry. Let me, oh. All right, so, oh. Let me open something here. I think it's in my downloads. Yeah. Okay, so the nice thing is while I was last week, I was having the issue of not being able to correlate basic blocks. Oops. But now, thanks to Snyder, there's a IL basic block, and I think also, no, okay, so I still have to do IL block first. Basic block, and then source block, and I can get back to the regular basic block from the medium level IL. So that's super exciting. So now also we should be able to do a, yeah. So I can see those. Now, do I need to do it to, I don't know if I need this one. Nope, that one's got it. And I believe this one also has it. Yep. Cool. So I can hash all of those, which means I can put them in sets, which is exactly what I want to do. So if you were watching last week, I was playing with the UI plugins thing. I'm actually not opening that right now because of the fact that I want that basic block thing. So I've got to get a new test build. Yeah, so I pushed my change into my fork and then made a pull request into Vector 35's. So I was hoping to do it earlier today, but I have actual work that I have to do, so I did not get to it. And I was hoping to have it for, like, get them to build it before stream, but I'll just have to wait for them to notice it and actually accept the pull request. So anyways, this is not the one I need. So let me get this one out of the way. So we were making a flow graph plugin last time that was then using a flow graph widget, and I actually moved some of this stuff around so that I can actually bring this into a normal thing. Oh, the basic block thing is not mine. The basic block thing was Ryan Snyder at Vector 35 added that during their little hackathon thing that they're doing this week. The thing that I just made a change on the fork to do was add a hash method to medium level IL functions and low level IL functions so that I can use them in sets. Because there was some reason I needed to use it in a set before and I couldn't. Oh, it was because I was trying to hash basic blocks, and the medium level IL basic blocks depended on the medium level IL function for their hash. So that's why. So anyways, I moved the UI related stuff into a try except block. So now I can actually bring this flow graph node into the regular binary ninja and make a flow graph report. Man, I'm forgetting my words today. So let's make sure that's actually working. see if this is working. Okay, yeah, so this is basically where we were last time. Still, yeah, still gives us stuff like that, which is nice. And if we change this, I think it'll actually update as well. Yeah, that's cool, huh? Anyways, so what I want to do today, because you notice the switch statements are the issue that we're having problems with. So the thing that I want to start with today is actually doing this the right way. Which means I need to save this somewhere. Yeah, you are in my plugins folder. So I need to move that to its own thing. Let me set up a folder real quick. I'm just setting up a new folder for this. I need to push some stuff to my repo, I think. I actually need to redo it a little bit and create a little bit cleaner directory structure. Of course, Visual Studio Code wants me to update now. Let's see if I can. Cool. All right, so I copied that in. And I want to start building an AST. We're probably going to need something from Binary Ninja. I'm guessing at least that. And probably that. Wish you could just do like medium level star and it would just grab everything. All right. So let's call it a LST. Actually, I don't like that. There we go. All right, and then we're probably gonna want some sort of container for our stuff. Yeah. So let's say oh, great. Well, it's effing around with Binary Ninja, Peter. It's not effing up with Binary Ninja. So let's see. Do I want a medium level IL basic block there? Or do I just want to... I think I just want to have it empty. And then do something like self.children equals this. And we'll start with that. And then this I want to do a medium level IL. Let's do function medium level IL function. Do I want to do it like the flow graph where this is the medium level IL AST? Maybe I want to do that. So just so it's self-referential. And then def append. Let's see. I want to do an append here as well. Now, do I want an append first nodes or insert? Because I'm going to be doing basic blocks in these, I think. Yeah. Actually, I want to have like a head node for this. I'm trying to remember. I should bring up the so there's a paper out there that I kind of want to loosely follow. It's called No More Go-Tos. So for the next like hour and a half, we're just going to sit here on the stream and we're going to read this paper. Okay? I'll read it out loud to you. No, I'm just kidding. Anyways, so they do structural analysis on everything, and I think a lot of this stuff is actually taken care of for us by the IL. And these are the the AST nodes that they do. So sequence, condition, loop, and switch. So that's what we want to do. We want to create nodes of those types. And so let's go ahead and make this IL AST node as well. I always want to do child like that. I don't know why. Apparently I'm a very old soul, an old English soul. So let's make a IL AST sequence node. With apparently with a list that says ass in it. Condition. Ugh. Am I typing in a different function window or something? Because every time I command tab, it like puts me somewhere else. What was the next one? Loop. And the paper is called No More Go-Tos. Decompilation using pattern-independent control flow structuring and semantics-preserving transformations. Here, I'll copy and paste this into chat so people can see it. And actually, I'll make it even easier. I will put a link. I've only read most of the paper. I haven't really gotten through all of it yet. So it's going to be kind of like a thing that we explore together. And then this one was a switch node. All right. So I think after that, there's like a... So the sequence one is pretty easy. It's just nodes of, just a sequence of nodes. Looks like oh, they have a call here too, but maybe that's just part of a regular node. Yeah, so they do a call, then they do that. So these are just sequences. And then let's, oh, I can't. Oh, what's the thing? From future import annotations. Yes, there. So if you're wondering why I just did that, from future import annotations will actually change annotations so that they get evaluated after the rest of the the script is evaluated, and so that means that you can use things like this right here that hasn't actually been created yet and defined. So let's move that over. Don't need it. So then I think we need a guess we need one of these, though not really. We'll do it just for the sake of being object-oriented out the ass. No, I don't need self. But I do need AST. I wish I could overload append. No, that's fine. Okay. So we've got our sequence node, and we can append our instruction nodes into it, as well as our condition nodes and our loop nodes and our switch nodes. So let's do something to, let's make this like that. And then let's add a nodes property. And I do that to get a copy of the list so you can't actually mess up the list. So we've got our nodes. We can get them from our AST. Actually, you know what? Let's do a root instead. And then here we'll do so we've got our children. And this one we'll do instruction. Got some horrible typing today. Then here, I think we want no, I don't think actually that one needs anything. The condition, though, needs a head node. And this one will do. Do I want to make this an instruction node? Let's make it an instruction node. And we'll do a let's raise type error. I think that's the right one to, yeah. And then self children will be all the stuff that's underneath it. So then we can do our def condition self return self dot condition. I think we can do something like this. I love type annotations. All right. Now, oh. Oh. All right. Okay, I think that maybe gives us enough to do some stuff. Let's see. Is there actual AST? Let me just see. What did I just... Oh. Yeah, there is an actual AST. So make it an init pi. What is it? All equals... Is that how you do that? No. Why can't you import that? It's literally right there. All right, let's see. See if that works. You're right there. What the hell is it having an issue with? Am I seriously going to have Python importing issues today? Okay, that's apparently why. 39, what is the issue? Oh, in Python 3. Okay, there we go. Okay. Can I do this? Yes. All right, cool. So let's give you a file on I think it already ran. Yeah. Let's get our function. Cool. All right, so let's say AST equals medium level IL AST func.mlil. Oh, I should add a repr to that. No root, and we should probably add something to handle that at some point. I want to just do all right, so if we make a let me see for IL in .mlil. Wait, no, that's not right. Actually, no. For IL in func.mlil.instructions, and we can just print out the instructions. I think this one's just a, no, it's got an if statement. Okay. Well, fortunately, we have the that block, the condition already set up. So func.mlil.basic blocks. If we get the first one, let's see. We're gonna see what the last instruction is. The last instruction is an if. So let's make a sequence block level IL AST sequence node. Oh, sorry. AST. All right. For IL in .mlil basic blocks 0, and we want everything except for the last instruction. I want to append a new medium level IL AST instruction node that is that. No, because I don't have a get item. Oh, the basic blocks don't have a slice thing. So we'll do it like this. Oops. Cool. So we've got our instruction nodes. And then we can do a sequence.append. Wait, no, let's make a condition equals a medium level IL AST condition node AST, and then here we'll make a medium level IL and AST instruction node. Actually, no. Yes, we'll make it an instruction node. Do I really need that to be an instruction node? We'll change it later, but I think I can just make that a an instruction. All right. So then let's see. What is our condition? Oops. So we have those two instructions. Those are our basic blocks. So true, let's do, wait, the next basic block in if UBB dot source block, the new thing, dot start equals condition. Let's make my terminal a little bigger. Instruction. Yeah, I feel like that can be turned into just, I mean, hell, I can probably just turn it into the instruction that is equal to the condition itself. Condition.condition.instruction dot true. I think this ends up being just the index. So let's do a .mlil there. This is long, but I'm just doing some like testing kind of stuff to see if it actually is working. Dot source block. Actually, I think blocks have a start, can have EQ and everything, so. Nope, that's not it. IL basic block. Aha. Nice. And then false, we can make the exact same thing basically. We'll just make this right here false. So we have true and we have false. Oh, that's beautiful. Thank you, Snyder. Oh, the hoops I was gonna have to jump through to write that statement before was horrible, and that just like cleaned it up so easily, and I'm so happy now. So we can do, let's see, what is true's last instruction? Is a return. So we can just do condition.append true. Oh wait, no, I need to do a medium level ILAST instruction node. True. And then sequence, we can append condition, and then we just append false. Wait, no, medium level ILAST instruction node, AST false. No, that is not what I wanted. Sequence.children. I need to pop that off. Okay, that's better. Okay, so sequence needs to append a medium level IL from there, no, I have to do a loop again. So false is the block, no return. Cool. So that one's not a jump or a go to or anything like that, so we can just do a for IL and false. Sequence.append medium level IL instruction. Oh wait, no. AST instruction node STIL. All right, so AST dot. Oh, and I need to actually append those children. Actually, AST doesn't need a children. It's gonna be, we just need root. Although, let's do nodes. Oh, fuck. I'm mad. I'm changing the wrong one. This is the one I wanted to change. Make sure this is a AST node of some sort. All right. And let's go ahead and make a tests folder. Actually, let's move init into here and move AST into here and there. And then we have tests, and we can do from Decompiler. All right. We'll basically just do the exact same thing we just did. Why is my terminal not working anymore? Oh, there it goes. No. Did it die? What the hell happened to the terminal? Visual Studio, you suck. All right. Ugh, brackets. Why did I do that? Let's just hard code this, because what's wrong with hard coding a file path? That goes ahead and updates and waits, updates analysis and waits, so I don't need to call it. So equals function at bb.symbols phase1 dot address dot as. Whoops. Really? What? Don't know why it just deleted that randomly. All right, so if we want to do this automatically instead of having to type it, man, it'd be nice to be able to see what I just literally just typed here, but I've completely lost it. That really sucks. Ugh, I'm just gonna kill it. Whatever. All right. So our AST is gonna be a, let's, oh man, is it not gonna work? Why are you not getting stuff from there? Why can you not? All right, let's try a new terminal and just check out what's going on. Wait. Okay, that seemed to work. All right, let's see. There's a thing here I can do. Python dot autocomplete. What was it? Imports. There's supposed to be another thing for imports. Extra paths. No, value expected. I mean, that is a value. Does it need to be string like this? There you go. Not like Python, it's like JavaScript, I guess. You gonna work now? No. All right. We'll just make this the whole thing. Let's see if that will work. No, you really don't like me today. You're gonna be annoying all day, aren't you? All right. Let's see what happens if we do. No, you're still not finding it. Oh, I guess it's doing it from the tests folder. That's annoying. Fine, I'll bring you out here for now, and then I'll figure out the path stuff later, because I don't want to spend an entire day just trying to get paths working. Okay, better. Cool, thank you. All right. Let's do visited equals set. And if I remember correctly, the paper actually does everything in post order. So let's look. Yeah, I don't care about unstuff. Where's the thing? I remember it being around here somewhere. Yes, so they do depth first search. If it's unvisited, then they put it onto the stack. All right, what's E? E is the set of edges. So they're doing it based on edges. And then this is the target. We haven't visited it, then we put it on the DFS stack. That's the source node. This is the top of the DFS stack. In T is the sink, it looks like. There we go. That's a little bit easier to read, huh? So we've got a source and a sink node. I'm not really sure. They just do a slice, I guess, between two arbitrary things. And they add a path of this. I don't know what SG is. Let's see if we can find that real quick. Okay, it's just the slice. So they're just determining what the what nodes it has to go through in order to get there. So the slice of D1 to N9 is then going to be these three nodes. It's going to be D1, then it's going to be probably D3. They push the nodes, not the edge. So how do they determine what the condition is? Oh, I see. They're doing a path, saying the path you take to get to N9, one of the paths is D1 to D3. And then it removes the visited nodes, which I guess means that the yeah, so it removes the visited ones. The visited ones are, I think, not the root node, just these. The root node always stays in the stack. So then it pops that one off, comes back up here, says, okay, there's another edge. Let's go to this edge, and pushes that onto the stack. And then it comes here and adds the path. If NT is visited already, then that means that it must be a loop, I guess. And so they add the path anyways. I'll have to read more about that. And then it figures out what the condition is of those. Okay. So that's the slicing part. There's something else that they do here. They have to also collect like the back edges and things like that. Here it is. Okay. They do a depth first search, over the CFG to find back edges, which identify cyclic regions. We don't have to do that because the basic blocks already have whether or not they have back edges. Then it visits nodes in post order and tries to structure the region headed by the visited node. And that is done by computing the AST of control flow inside the region and then reduce it into an abstract node, which is what we're doing by containing everything in like a sequence node. Post-order traversal guarantees that all descendants of a given node are handled before in is visited. So here's what we want to do for a basic block. If n is the head of an acyclic region, we compute the set of nodes dominated by n and structure the corresponding region if it has a single successor. If n is the head of a cyclic region, we compute loop nodes. And if the corresponding region has multiple entry or successor nodes, we transform it into a semantically equivalent graph with a single entry and single successor and structure the resulting region. And I believe that that would be like our switch node, where it would be, we'd then create a sequence node that has the switch at the top and then goes through all of the, like has its children, and then put an entry or a sequence node at the end of that. The last iteration reduces the CFG to a single node with the program's AST. So yeah, it sounds like I'm working on making pseudocode for medium level IL, basically. I'm not writing an actual yes, Twitch plays Whitepapers. I know, this is probably like the most interesting Twitch stream on the planet right now. Like, why would you want to watch video games when you can look at a white paper? All right, so now that we've kind of looked at that, I'm not going to follow this perfectly, I think, because I'm not actually writing a true decompiler. I can probably get away with missing some stuff. So I think maybe that means that we can let me look at what happens if we do. Actually, let's go back to Binary Ninja. It'd be easier since it's already here. Yeah, this is my garbage input right now, or output. Let me do the do one that actually like kind of does look nice. Oh, wait, no, I do this. Yeah, so that one looks pretty nice. Let me change that. Ooh, that's interesting. Wonder why that changed. Huh. Let's see what's happening in the regular medium level IL when I do that. That's weird. It just really doesn't like me renaming it arg1. Oh, I bet because they're both version 0. And so it's probably something having to do with the AST, the SSA form. So, well, yeah. Yeah, what happens if I do this? No, it'll do that. Huh. Weird. Let's see, did that update over here? Yeah, that's cool. And then we can change this to success. Or no, strings equal. Yeah, that's confusing because it's strings not equal. Oh, let's do strings not equal. There we go. That's cool. So yeah, so it's gonna look something like that. Let's see. So anyways, what was I coming over here to check? Current mlil.basic blocks. I wanted to see, are we in depth? I think these are depth first search already. So oh, those are hex numbers, that's why. So 33 is 51, which is gonna be down here. And then the next is 49 to 50, which is gonna be here. That makes sense. And then 32, which makes sense. Because all of these that might be breadth first. Maybe we're not depth first. I would have actually expected this one for it to be 16, 17, then 18. Well, actually, is that because this one creates all of these nodes, and then we get this node, which then means that what we'll get is this, this, then this, then this, then this, then this, then this, and this. I don't know if this is true post order, but we're still guaranteed that we'll do all of these before we do a parent. So then we come here, and then we'll do all of these. And then we'll do this one. And then we'll do this one. And then we'll do this one over here. And then this one, and then this one. So yes, so we can go backwards in the basic blocks and be guaranteed that our parent will be, this is a pretty good exemplar for doing stuff. Let me get that. So we'll do the reversed. So first we can do let's see. We'll do a sequence equals mlil. Still not getting me my things. Instruction node. I don't know why you're not annoying. I think I want to add in here, when this does this, to do ast.append self. Yeah, so I have all the nodes. I need a remove though too. Can I do that? I think there is a remove, right? Yeah. Because I think I'm gonna be removing some of those out and stuff. So we've got our sequence. No, I don't want instruction node. I want sequence node. What am I doing? Was it sequence node like that? Man, I'm really annoyed with Visual Studio Code right now for not giving me my this isn't what I want. Actually, yeah. No, I'm fine like that. All right, so for IL in, so we're doing reversed. So I want to actually make here's the thing. So when I come into the sequence, I'm gonna do something like for IL in BB sequence.append instruction node AST IL. But if IL.operation is not equal to operation, jump to if and then if it is an IL operation, dot IL if, then what I want to do is no. So I want to Maybe do the ILs, the instructions backwards as well. Let's do those backwards. I think I want to add these blocks to the children as like a dictionary eventually that's actually corresponding to the basic blocks, and that way I can find them. Yeah, I think I want to make this like this. And I don't want to do append and remove. I think I want to do get item. I don't know how much I like this either. I think I might want to do something slightly different. How do you delete an item? Is there like a... No, there's not del. How do you do like... If I do something like delete AST BB like that, does it know how to do that? Would it know to then remove nodes BB? I don't know. Guess we'll find out at some point. Actually, let's do a pop. I believe that will pop a key. Doesn't raise anything, does it? Yeah. I don't want to raise anything if it's not there. Actually, yeah, I do. Should always be explicit about that. Okay. So this doesn't exist anymore. Okay. I don't actually know if I need this, but I'll leave it just in case. So then if we do reversed, like that, I don't want to append anymore. So then append doesn't really make much sense. I'm just trying to think here. Actually, why don't we do just like that, and then do like that, and then that's because this is what I was doing on the command line. Do like that, and then if bb-1 dot operation then we can make a condition maybe this should be a current node. Yeah, let's move this here. And then, because we're still going backwards, so I don't want to do that necessarily. Huh. Yeah, let's add a prepend to. I wonder if I want to use a deck. Let's see. Can't remember how Python decks work. Okay, it has an append left, which is what we want. And incur O in memory movement costs. So, yes, max len is not specified. Decks grow to an arbitrary length. That's good. Yes, this is what I want. So this is, I can append left on this, and it will work. So we are going to make this no, I don't want a default dick. I want a deck. Children is going to be a deck. And I'll leave append. And we'll leave list, because we don't need to give it back a deck. And I'm going to call it prepend, because I don't like append left. that E thing again every time. All right, so we're gonna and we'll do reversed here. And that way, we can keep using this and I need to actually add, actually the sequence thing will work fine. Let's do this. AST BB equals sequence, because we haven't seen it yet, so that should be a good thing. So that way, actually we'll say current node. Actually, no, sequence is fine. We're always going to use a sequence node. All right, so condition is going to be a medium level IL AST condition node that I need to import. And then this will be AST, and then it will be BB -1. And then condition dot append, because there's nothing in its children right now, we can do that. That is going to be AST or I need next MLIL dot basic blocks BB for BBin if BB dot start equals true. Actually, did I change that or not? Yeah, I'm gonna change this since I'm thinking about it. All right, so now I can do condition dot instruction index and then we can do sequence dot append condition to put it at the end of the sequence. I'll do this one. I haven't actually done IL jump to is not implemented. Else. Actually, I'm not going to append that. L if doesn't equal medium level IL operation dot IL jump. Then we just add BB1 to the end. Then the last one is going to be the jump. This might still also be an issue. I need to know if this is a loop. What am I? Can't remember what my. Do I have any loops here? No. Any loops here? Yes, this one has a loop. Okay. Current MLIL basic blocks. I want 12, so that's minus 3. Yeah. The true branch is the loop. Let me see, is that, I think it says back edge. Yeah, it is back edge. So, and true is always first as far as I've found. So what do we do if it's a loop? So if we start here, we do a sequence, we create a sequence node, we come here, we are still in that sequence node. I think I want to do everything backwards. Yeah. So we don't want to do that. We want to do a reverse list. And here is where we do this. So we create the condition here. We're going to make a so then we want to do if IL dot basic block dot outgoing edges 0 dot back edge. So if we do this, this is going to convert it into a then we need to do a loop one. Then we need to make the sequence for this first. I wonder if I can. If it's a back edge, then let's do a back edge node, which is going to be another medium level IL sequence node. And we will say AST of file.basicBlock.outgoing edges 0 equals the back edge node. So the node exists now. And we can say if bb not in AST else sequence equals AST. That's gonna lose our reference to sequence, but that means that there's probably already been put on something. We'll figure it out. I'll figure out what to do with that later. Okay, so we've got our back edge node. Actually, we'll just say true node. Call this true node, and then we can say else true node equals sequence. And then we can append true node. And from here, no. Yeah, we can just call that an edge. We'll consider children to be edges as opposed to, yeah, I should have called them edges probably. Anyways, so faults the faults node is a back edge, which, yeah, that's possible, I think. No, is it possible? The faults edge isn't. I mean, you could probably do something like that with, I mean, you can do it with the IL, but is that ever really going to happen in an instruction? I'm going to just raise not implemented here for now. false node equals, this is where we do the next BB for BB in actually, this I don't have to do now because I can just do AST of condition.condition.false. No, I do still need to do basic blocks if pile no dot false no bb dot start equals il.false. And so here sequence now without false node is guaranteed to be something after it if it's not a back edge. Which means that we should have already seen it. Which means that we can say false node dot false node dot prepend condition. I think. And then actually we can make this and then ASTBB equals sequence. And then we'll just keep stepping backwards. That'll be our else statement. Our jump to, that's going to be our switch statement that we'll get to in a little bit. And then, because I really just want to be able to do let's see, get rid of all that. If it's a jump, we've seen already, then get that sequence block. If il dot il basic block dot outgoing edges, the jump will only have one. Wait, no, it's a go-to that I want. So jump will be something outside of the function. Whereas a go-to is going to be something in the function. If the target in AST I need to do wrong one. Keep doing that. Isn't it contains? I think it's something like that. All right. If it's in the AST, then sequence equals ASTIL. Oh. And then we'll prepend actually we don't want to prepend, it's just a go-to. If it is, if it's not in the no, this is not what I want. I want outgoing 0 target. So that's guaranteed to be there since so here, if il dot il basic block dot outgoing edges 0 dot back edge. We'll deal with that later. Ugh. Okay. And we do that, but don't prepend the goto because we don't need it. Or do we? Let's see, maybe we do. If, let's see, go to target is this. Maybe we need to do if go to target dot incoming edges What happens if you have two incoming edges? I'm not sure what to do right here. So I'm thinking about like where stuff's nested. Let's see. Like this is where the go-tos, the no more go-tos part comes in. Is how do you represent this? Going back and making the it's not even really the so like here, even without loops, what am I looking at here? I have this whole thing right here will be in the, let's do this. So we have this sequence block, then we get here, and then next we're going to do this block. Oh no, we're not gonna, yeah, so then that's going to be a different sequence block. Then we're going to do this one. And it's true is going to come in and put this here. and then it's going to come up to this one, and it's going to create that sequence block. That's what I need to do here is, so I do need to make a new sequence block basically. For each one. Or I guess if it's not if it's like a no return or something like that, I should just make a new sequence block. Wonder how many things can end a like what terminates a block. We can assume that MLIL ret, there's a ret hint apparently. Not sure which one that is. Ret hint. Level dot and then I feel like there's some other ones that we can do as well, like tail call. God, tail call untyped. Tail call typed. And then what was the last one? Jump. And undefined, I think. I think jump is going to be one that is like jump to this register, but I don't know what this register is, so this just kind of stops there. Trap. This is a very long tuple. Is there an interrupt? No, it doesn't look like it. BP. I'm pretty sure that BP will stop an undefined. So if it's one of those, then we're at the beginning of another sequence node. And then we can do a prepend. Actually, it's a new one, so I'll just say append, doesn't matter. Oh, my stomach is grumbling. Hopefully y'all can't hear that. Oh. Let me see. I don't think they do the slicing stuff until after reaching condition. Yeah. So the back edge is to identify the cyclic regions. Tries to structure the region headed by the visited node. Structuring a region is done by computing the AST. Post-order traversal guarantees that all descendants of a given node are handled before in is visited. So I might want to actually go through all the back edges and say, okay, we know that these are acyclic. The N is the head of a cyclic region. Compute loop nodes. Okay, so they do multiple iterations actually. I don't want to deal with loops yet. So we're still kind of at this point. Let me go back and because I got distracted from this part. So we create this node, then we create this node, then we create a condition node that would be this. That would condition node which has this nested under it. This should really just be the opposite of this. If we invert this branch, wait, that didn't update the, that's not what I wanted. I want to invert these, not, but I can't do that, I guess. Actually, no, we would start here and build this one. Then we'd build this one. So we'd have two sequence nodes. Then here we would say this condition comes here. So the condition would have this nested underneath it. Then it would be added to the sequence of this one. And then we would continue up this way. And then we would get here and we'd do another condition where this one is nested and this is the sequence. This one gets prepended to this sequence. Then, wait, no, we wouldn't visit that yet. We would visit this first. And this go-to would come here. So then how do we handle this if statement here? This is, I think, where they come into the slicing thing with the reaching condition. But I don't know how this would be structured, because you've got this in file here and an in file here. It would be better if these were inverted, if this was the true and this was the false. So if EAX is 1, then it comes here and goes down here. If it isn't 1, then it goes down this way. Like, I feel like in C code, this would have been the opposite. Because I think this would be structured as this one, then if EAX equals 1, like I could see this being the if statement here. If EAX isn't equal to 1, then it comes in here. But then this one would be switched so that it would be if EAX is 0, then do this stuff. Otherwise, it just falls through to here. And then this one would be the falls through as well. So how do they build the AST before they do the reaching condition stuff? Or do they just not care? And should I be doing this on the SSA one? Well, I can get to the SSA for the conditions if I really need to. Let me see. So they compute the structuring acyclic regions proceeds as follows. Regions proceed as First, we compute the lexical order in which code nodes should appear in the decompiled code. Then for each node, we compute the condition that determines when the node is reached from the region's header, denoted by reaching condition. In the second phase, we iteratively group nodes based on their reaching conditions and reachability relations into subsets that can be represented using if or switch constructs. Okay, so they can first phase is our algorithm is cover control flow abstractions and compute the corresponding AST. Structure the region headed by the visited node. It's not a cyclic region, though. Okay. If the corresponding region has multiple entry or successor nodes, we transform it into a semantically equivalent graph with a single entry and a single successor. And that is section 5. Semantics performing control flow transformations. I don't need loops, though. That's the only types of regions that cannot be structured by our... No. It's an acyclic region. There's no cycles. So if it's not a... It's an acyclic region is what I want. Compute reaching conditions from the region header to every node in the region. Okay, so they do the reaching node thing, which means that I do need to implement that stack thing first. And I think maybe I need to be doing this on basic blocks to create the initial AST. But I don't want to do that because of the if statement thing at the end. I want to add that as a condition. Okay. So they do like this, but that's not what we would do because we already have the if then else construct. But do they have to? Although maybe they would do. How would they do it? Would they do like a? So let's see. What would the reaching condition be from this node? It doesn't. They don't really seem to describe what they do for like multiple. Okay. To two disjoint components, simple path component and cycle component. Target node is reached if only P is followed, or if PS and PC are traversed, cycle is executed. Therefore, the condition represented by P is condition P equals this or this and that. Finally, evaluates condition P of S. Represent the currently explored simple path from the header node to the currently visited node. Popped when all their descendants have been discovered, and each iteration of edge exploration, the current path represented by is added to the slice when traversal reaches the sync node or when it discovers a simple path to a slice node. Line 12. And that's, so the slice node is the cycle thing, which means that it's already found let's see, the path simple if the target of node E is not in DFS stack. Okay. Okay, so this is saying this is the false branch on D3, and this is the false branch. Okay, so that's branch dependence then. So if we do wait, no, I don't have branch dependence for the block. Yeah, that doesn't have this would be incoming edges. Oh. So that would then be, for this one, the reaching conditions would be this block and this block, or this block and this block and this block. All right, I feel like I have to do this then. I feel like I can do reaching condition backwards, because but that tells me, yeah. But then this one has branch dependence. Yes. So I'm really confused. So they do depth first search, and then they do the reaching condition for each of these. Okay, I think I see. So they create a slices of every node to every node, basically. Like, okay. So we would then start here, and we would say slices is nothing because it has unexplored edges. No unexplored edges. Then we would come to here and we would say slices are nothing because there's no unexplored edges. Then we would come here and say, okay, there are explored edges, unexplored edges. So we will go this way, and the slice is now this, and that's it for that one. And then this one is going to be not this. And then we'll go here, and there are no reaching slices because there's no edges, then we would come here and we would say, okay, there's a edge here. So the slice to this is this, and that's it. And then we'd come here and say there's two edges. So then we'd create the slice of this, and then we would create the slice of all of these, I think. I think it does it for every single edge. Or is there a single sink and that's what we're supposed to be? Do we just calculate what all the sinks are? So do they then? Okay. For each node, we compute the condition that determines when the node is reached from the region's header, denoted by the reaching condition. And so we need to collect the slices for every single thing, and then that is what we can use to calculate the condition to get to the end. Okay. So yes, we do it to every node that we've already seen, I think. Oh, to all of its dominators, I think. Let's see, what are this one's? That's the part I'm missing, I think. I should have thought about that earlier. Oh, wait, no, not dominators, child. Is it child tree dominators? No. It's not strict dominators. Dominator tree children. Whoops. Failing at copy paste right now. Oops. Okay, so that only gives me its immediate descendants. Because I should have also gotten 96 as well. But if I do 96 basic block and do dominators, I should get 6. Yes. So what I need to do then is calculate the dominators of, what's the dominance frontier? I can never remember which one that is. Oops. Not actually sure what that is. So let's look up dominance frontier. It's a set of all nodes in such that D dominates an immediate predecessor of M, but D does not strictly dominate N. Is a set of nodes where D's dominance stops. This is where D's dominance stops. So then that doesn't tell me that this one is part of it. I want the opposite of dominators. I want like dominator tree children, except I want dominator tree children seems to just give me these two. It should give me this, I thought, too, because this strictly dominates this. It should, like, you cannot get to this basic block without going through this one. But I think we need to do something where we, I don't remember what I was going to put there for now. Dominators. Actually, let me see. Yeah, it just gives me the BB. D not in dominators. Okay. Let's try this in. Oh, bless me. Of course, dominates itself. That's not a surprise. So then this dominates this and this. It dominates everything. That makes sense. These dominate each other themselves. 11 to 18 dominates this one and this one. Okay. Cool, that's what I wanted. So then that can, and then let's do, oh, I got an end zone. For BB. And then these we do backwards, I guess. Oh, I don't actually need this. I don't think. I think I can just do it with reverse basic blocks. Yeah. I think that was a complete waste of time. So dominators is for D and BB dot dominators. Here we calculate the graph slice. So this is then where we come here and we do this. So while for E in D dot outgoing edges, this would be the DFS stack so we get the next edge. In T equals E dot target, and then remove visited nodes. I don't think we're gonna visit anything that's not. Oh, okay, I see what we're doing. So we go in T, I think we do visited equals set here. And this is going to be D to start with. And this is going to be we do the reaching. Do we do the reaching condition on just the acyclic? Break statements. Okay, so they do the reaching condition. Okay. All right. I'm gonna add D to this. int t equals the target if int t is visited oh, that would be the other one. If int t not invisited, then where's Tim Apple? I don't know. It's a really weird question to ask. Add in t, and then also dfs stack dot append in t. Let's see, if int t equals bb, then slices actually, let's do graph like that, and then okay. Let's see. Oh, that goes under here. And then elif int t int t is in the slice? What? What? That doesn't make any sense. int t isn't an element. It shouldn't be an element of this set anyways. Or are they saying that it's in a... Or are they saying that it's in SG somewhere? Are they saying it's in any path? Or are they saying, oh, maybe they're saying that oops. Maybe they're saying in T BB in graph slices and in t not in DFS stack. I think that's what they're saying. Then we add that path. And we go ahead and just add the DFS stack. I think that's what they mean by that. And then yeah, so then here we remove here and then just say visited, add D again. Oh wait, no, that's not what I mean. We want DFS stack, right? Yeah, we remove the visited nodes from the DFS stack. Popped when all their descendants have been discovered. No, it's they're getting the edges from the graph, not I'm doing more of a breadth first right now. I should have been doing a depth first. Hang on a second. Can we do this without doing this part? I think we have to push the edges. I'm really confused right now. Why am I removing visited nodes here? I feel like that should be like a recursive thing. Yeah, I need to do it slightly different because I already have all of the dominators. think it's here is where they do the visited. And they do a list. And I don't need to do that. They're not really like talking about, it's like they already have all the edges. DFS next edge, so then I would do int equals edges dot I don't want to do this. I want to do while edges. That's e equals edges dot pop. And then I think I can do that there. Edges dot append in t dot outgoing edges. Yeah, I'm in a lot of trouble figuring out where to put visited. Yeah, I think that's what I want. Then it comes in here, it does that, and then it comes here. I'm confused as to where it removes the visited nodes. And popped when all their descendants have been discovered. I think it removes. Man, I wanted to figure this slice thing out first, but I actually need to go. I've got like 5 minutes before my kids get home today, so we will continue this later. I'm gonna think about this. I might solve this problem on my own instead of just sitting here staring at the screen while everybody else is just kind of wondering what the hell I'm thinking. So yeah, that was fun. Twitch does white papers, and had a little bit of get fun at the beginning. So we'll continue this on Thursday at 3 p.m. Pacific. That's 6 p.m. Eastern. And yeah, thanks for hanging out and sticking through some pretty heavy stuff, I think. Hopefully we'll get into some even more fun stuff next time. But until then, I hope we all have a good night. And of course somebody says, hey, right as I'm signing off. So, hey, also, bye.